Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money, a Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime Series 26, Episode 75, for broadcast on the 23rd of June 2023. Coming up on SpaceTime, new clues as to how the Earth got its water, the world's largest atom smasher tightens measurements on matter-antimatter asymmetry, and astronomers are angry over new satellites. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Sodium chloride, better known as table salt, isn't exactly the type of mineral that captures the imagination of scientists. However, a smattering of tiny salt crystals discovered in a sample from an asteroid has researchers at the University of Arizona excited because these crystals can only form in the presence of liquid water. Even more intriguing is the fact that the sample came from an S-type asteroid. That's a group which is known to lack hydrated or water-bearing minerals. The samples were collected from the asteroid Itokawa back in 2005 by Japan's Hayabusa mission and brought back to Earth in 2010, landing at the Woomera rocket range in outback South Australia. The discovery strongly suggests that a huge population of asteroids hurtling through our solar system may not be as dry as previously thought. The findings, reported in the journal Nature Astronomy, gives renewed push to the hypothesis that most, if not all, the water on Earth may have arrived by way of asteroids during the planet's tumultuous infancy. What makes the study so important is it's the first to actually prove that the salt crystals actually originated on the asteroid's parent body, thereby ruling out any possibility that they may have formed as a consequence of contamination after the spacecraft reached Earth. That's a question which has always plagued previous studies that have found sodium chloride crystals in meteorites of similar origin. One of the study's authors, Tom Ziegler from the University of Arizona, says these grains look like nice square crystals, exactly what you'd see if you took table salt at home and placed it under an electron microscope. Ziegler says the Itokawa samples represent a type of extraterrestrial rock known as an ordinary chondrite. These S-type asteroids make up about 87% of all meteorites collected on Earth, but very few of them have been found to contain water-bearing minerals. Ziegler says it's long been thought that ordinary chondrites were an unlikely source for Earth's water. But the discovery of sodium chloride on one of these asteroids tells scientists that the asteroid population could harbour much more water than previously thought. Today, many scientists think that Earth, along with other rocky planets such as Venus and Mars, formed in the inner region of the rolling, swirling protoplanetary cloud of gas and dust around a young sun known as the solar nebula or planetary nebula, where temperatures were very high, too high for water vapor to condense out of the surrounding gas. In other words, the water on Earth had to be delivered from the outer reaches of the solar nebula, beyond the so-called snow line, where temperatures are much cooler and allow water to exist, usually in the form of ice. The most likely scenario is that comets or other types of asteroids known as C-type asteroids, carbonaceous chondrites, which reside in the outer reaches of the solar nebula, migrated inwards and delivered their watery cargo by impacting the young Earth. The problem is the water found in comets has a different hydrogen to deuterium ratio compared to the water found on Earth. And we see that throughout the solar system. The further out from the sun you go, the more the hydrogen to deuterium ratio in the water changes. The discovery that water could have been present in ordinary chondrites and therefore have been sourced from much closer to the sun than their wetter kin has real implications for any scenario trying to explain the delivery of water to the early Earth. The sample used in this study was a tiny dust particle spanning just 150 micrometers, roughly twice the diameter of a human hair. From this, the team cut away just a small section about 5 microns wide, just large enough for analysis. The authors were able to rule out that the sodium chloride was the result of contamination from sources such as human sweat, the sample preparation process, or simple exposure to moisture in the laboratory air. Previous work, led by the late Michael Drake in the 1990s, proposed a mechanism by which water molecules in the early solar system could become trapped in an asteroid's minerals and even survive an impact on Earth. Those studies suggested that several oceans' worth of water could be delivered by this mechanism. If it now turns out that the most common asteroids in the solar system may be much wetter than previously thought, that'll make the water delivery by asteroids hypothesis even more likely. Itokawa is a peanut-shaped near-Earth asteroid about 600 meters long and 230 meters in diameter, and it's believed to have broken off from a much larger parent body. It's conceivable that frozen water and frozen hydrogen chloride could have accumulated there. Ultimately, the parent body would have succumbed to pummeling and broken up into smaller fragments, leading to the formation of Itokawa. Once these ingredients came together to form asteroids, there's the potential for liquid water to form. And once you have liquids form, you can think about them occupying cavities inside the asteroid and potentially doing water chemistry. However, the evidence pointing to the salt crystals in the Itokawa samples being there since the beginning of the solar system doesn't end here. The authors found a vein of plagioclase, a sodium-rich silicate material running through the sample, which was enriched with sodium chloride. Now, when scientists see these sort of alterations in veins in terrestrial samples, they know they're formed by aqueous alteration, and that means water must have been involved. The fact that we're seeing this associated with sodium and chlorine is another strong piece of evidence that this happened on an asteroid as water was coursing through the sodium-bearing silicate. It's a fascinating story. This is SpaceTime. Still to come, the world's largest atom smasher tightens measurements of matter-antimatter asymmetry, and astronomers are getting angry as super bright satellites are destroying their valuable research. All that and more still to come on SpaceTime. Physics tells us that the Big Bang would have produced equal amounts of matter and antimatter when the universe came into existence 13.82 billion years ago. And we know that matter and antimatter annihilate each other whenever they come into contact. So, the physics tells us the universe should have disappeared in a blue gamma-ray explosion virtually as soon as it appeared, leaving nothing but radiation behind. And yet, here we are. The universe clearly exists, and it's made up almost entirely of matter. So, that means something must have happened to create an imbalance. But what was that? The weak nuclear force, the standard model of particle physics, is known to induce a behavioral difference between matter and antimatter, known as charge parity, or CP symmetry violation. This happens in decays of particles containing quarks, one of the basic building blocks of matter. But these differences or asymmetries are hard to measure, and they're insufficient to easily explain the matter-antimatter imbalance in the present-day universe. And that's prompted physicists to measure precisely the known differences and to look for new ones. At a seminar held at CERN, the European Organisation for Nuclear Research, the L8CB collaboration are reporting on how they measured more precisely than ever before 2 key parameters that determine such matter-antimatter asymmetries. Now, our story begins back in 1964 when James Cronin and Val Fitch discovered CP symmetry violation through their pioneering research at the Brookhaven National Laboratory in the United States, using decays of particles containing strange quarks. Strange quarks are one of 6 known types or flavors of quarks. the others being up and down, top and bottom, sometimes called beauty, and charm. The findings challenged the long-held belief in the symmetry of nature, and it earned Cronin and Fitch a Nobel Prize in Physics in 1980. Then in 2001, the Babar experiment in the United States and the Bell experiment in Japan confirmed the existence of CP violation in decays of beauty mesons, particles containing a beauty quark, solidifying science's understanding of the nature of this phenomenon. By the way, in particle physics, a meson is a type of subatomic particle composed of an equal number of quarks and antiquarks, usually one of each. And because matter and antimatter annihilate each other, these mesons don't live for very long. The achievement ignited intense research efforts to further understand the mechanisms behind CP violation. In its latest studies, using the full dataset recorded by the L8CB detector at the CERN Large Hadron Collider, the world's largest atom smasher, the L8CB collaboration set out to measure with high precision two parameters that determine the amount of CP violation in decays of beauty mesons. One parameter determined the amount of CP violation in decays of neutral beauty mesons, which are made up of a bottom antiquark and a down quark. This is the same as that measured in the Babar and Bell experiments in 2001. The other parameter determines the amount of CP violation in decays of strange beauty mesons, which consist of a bottom antiquark and a strange quark. Specifically, these parameters determine the extent of time-dependent CP violation. This type of CP violation stems from the intriguing quantum interference that occurs as a particle and its antiparticle counterpart undergo decay. The particle has the amazing ability to spontaneously transform into its antiparticle counterpart, and vice versa. Now, as this oscillation takes place, the decays of the particle and antiparticle interfere with each other, leading to a distinctive pattern of CP violation that changes over time. In other words, the amount of CP violation observed depends entirely on the time the particle lives before decaying. This fascinating phenomenon provides physicists with key insights into the fundamental nature of particles and their symmetries. For both parameters, the new L8CB results, which are more precise than any equivalent result from a single experiment, are in line with the values predicted by the standard model. L8CB spokesperson Chris Parkes says these new measurements are interpreted within our fundamental theory of particle physics, the standard model, improving the precision with which science can determine the difference between the behavior of matter and antimatter. Now, these are key parameters that aid our search for unknown effects beyond our current theory. Future data from the third run of the Large Hadron Collider and the collider's planned upgrade, the High Luminosity Large Hadron Collider, will further tighten the precision on these matter-antimatter asymmetry and perhaps even point to new physics phenomena that could help shed new light on what, after all, is one of the universe's best-kept secrets. This is SpaceTime. Still to come, astronomers are angry about a new super-bright satellite orbiting the Earth, and later in the science report, bad news if you're a night owl. Chances are you'll die early. All that and more still to come on SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Over the past few years, astronomers have become increasingly concerned over the growing number of satellites orbiting the planet, which are now causing serious disruption to vital scientific research. Huge multi-thousand satellite constellations like Starlink and OneWeb are already filling the skies with what have been dubbed satellite trains, long trails of satellites streaking across the heavens, one after the other. Now, current plans could see as many as 58,000 of these satellites in orbit by 2030. However, in September last year, that situation was made infinitely worse by the launch of a massive new satellite, Blue Walker 3. This monster carries the largest antenna of any commercial telecommunications satellite to date, a reflecting surface some 40 times brighter than any other. A committee of the International Astronomical Union, the international governing body of astronomy, has denounced the launch, warning of the dangers posed by the satellite and its successors to scientific research. Blue Walker 3 doesn't just reflect more sunlight, glinting more than any other satellite, but it also emits really strong radio waves, potentially affecting radio astronomy as well. Now, Blue Walker 3 is just a prototype, but the company behind the spacecraft, AST Space Mobile, say they're planning an entire constellation to be called Bluebirds, which will eventually involve even bigger satellites, possibly up to 168 of these giants. Jonathan Nally, the editor of Australian Sky and Telescope magazine, says Blue Walker 3 is hard to miss as it crosses the sky.
Now, satellites, as we probably all know, satellites generally have lots of shiny bits. Particularly their solar panels, and these surfaces spray reflected sunlight all over the place, including down towards cameras and telescopes on the ground, and they can tend to ruin pictures that astronomers are taking. Now, this didn't really matter years ago when there were very few satellites up there, but astronomers are becoming more and more worried about the effect that hundreds or thousands of new satellites in orbit will have on their observations. Now, a new satellite that was launched not too long ago called Blue Walker 3, it became 40 times brighter after it was launched, once it opened up its solar panels. Right? When the solar panels were closed up, it wasn't too bad, but as soon as these solar panels opened up, it became 40 times brighter because these panels reflect sunlight really, really well.
64 metres or something across, aren't they?
The company that owns it, AST Space Mobile, plans to launch 100 more of them by the end of next year, and each one of them will have even larger solar panels than this Blue Walker 3. Now, of course, we can't pin all the blame on this mob because the Blue Walker satellites, the drop in the orbital ocean, if we can call it that, there are already thousands of satellites up there, and there are tens of thousands more planned. Starlink alone, this is the communications satellite, Starlink alone wants to orbit at least 30,000 small satellites, each of them glinting and glaring away as they cross the night sky. And it'll eventually reach a point, if all this goes ahead, it'll reach a point where every single picture of the night sky will probably have at least several satellites going through it, spoiling the view and potentially ruining scientific observations. You know, decades from now, if all this happens, we'll have kids growing up never knowing a sky that isn't being crisscrossed permanently by satellite trails and things. Sort of takes me back to the 1980s when someone proposed putting a big illuminated advertising billboard in orbit.
Coca-Cola thing, yeah.
That sort of thing, yeah, and everyone jumped on that, of course. I mean, it was never going to go ahead. But
next thing they'll be launching balloons with Goodyear written on it.
That's right, yes, yeah, and floating across countries they're not supposed to be over. So anyway, if this happens, I mean, it's going. Well, what happens if it gets out of control? What happens if all these tens of thousands get up there? Well, you know, if it really does ruin the night sky for astronomers, what are they going to do? Well, maybe they'll just have to come to rely solely on telescopes that are themselves up in orbit, like the Hubble telescope or the Webb.
Is that where it's going to be eventually, that astronomy will have to be done from orbit? Because it's not just the optical telescopes, radio telescopes as well. They're put in radio quiet areas for a reason, and those areas are legislated by law to be radio quiet. So if we have these sort of satellites that are just raining down electromagnetic radiation on the surface, are we heading for a situation where astronomers will have to work remotely with telescopes in space and on the moon and things like that?
Well, if it keeps going the way it's going, then there'll probably have to be an element of that. I don't know how much we'll have to come to rely upon that, but certainly it's polluting the night sky. And look, they can't be too thingy about it because we do need satellite communications and other stuff as well. Yeah. But look, maybe there'll be a solution where they'll be able to use clever computer programs or something to, if they get a satellite trail going through a picture, they'll be able to, magically remove it or something. Filter it out, yeah. And with the radio telescopes, for instance, too, I mean, it might mean that certain radio bands are affected. But what they actually do tend to do, and this is an important point, particularly when it comes to radio, probably more so than the optical band, that is that radio frequencies around the world are heavily regulated, and they keep things apart, so certain uses of certain part of the radio spectrum must not interfere with other parts. So there are whole regions of the radio spectrum that are set aside just for radio astronomy, and no one else is allowed to use them for anything. And there are certain parts of the spectrum that are set aside for the remote control door in your garage, or Starlink communication satellites, or the radio walkie-talkies that police use, or television broadcasts. They've all got their own segment of the radio spectrum separated off, and the whole scheme is designed to try and minimise what they call harmful interference between one part of the spectrum and the other. So as long as all these communication satellites up there doing radio transmissions stick to the frequencies that they're supposed to, and they will because they'll get heavily penalised if they don't. We should be okay. There's an interesting thing at the moment going on in America. There's big discussions about the interaction between GPS signals and new 5G mobile telephone signals going around. So they're worried about harmful interference between those two things. So it's got to be carefully done. But my main concern is not so much the radio, but the optical telescopes and the sunlight glinting off the satellites flying above. When we have tens of thousands, if all the plans go ahead, we're looking at something like 70,000 satellites up there, and most of them pretty low down, and all of them glinting sunlight. It's going to change things completely.
One of the SpaceX Starlink satellites was specially coated to try and reduce the glinty. I take it that didn't work too well.
Well, they say they're trying to do that. They are making efforts, but I think there's only so much you can do with that, because you do have to make a lot of your parts of your satellite pretty shiny. I think it's just going to be the number of them is the problem. Even if you've got satellites that are half as glinty as before, if you've got 500 times more of them, it's a problem, So who knows what's going to happen? I really don't know.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And this is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has found that people with higher IQs were only quicker when tackling simple tasks, but actually took longer to solve difficult problems compared to those with lower IQ scores. The findings, reported in the journal Nature Communications, tested 650 participants, finding that less intelligent people tended to literally jump to conclusions when making decisions, rather than waiting until upstream brain regions could complete the processing steps needed to solve more difficult problems. Participants were asked to identify logical rules in a series of patterns. These rules became increasingly complex with each task and thus more difficult to decipher. In everyday terms, an easy task would consist of quickly braking at a red light, while a hard task would require methodically working out which is the best route on a road map. The authors found that although more intelligent people needed more time to solve difficult tasks, it turns out they make far fewer errors. Paleontologists have discovered the fossilized remains of a giant armoured shingleback lizard. The findings, reported in the Proceedings of the Royal Society B Biological Sciences, were made by researchers from Flinders University. The lizard's being described by its discoverers as by far the largest and most bizarre skink that ever lived. While related to the much smaller brown skinks or shinglebacks found in gardens today, Tulcafrangians was as big as an arm and covered in thick armour. Well, bit of bad news now. If, like me, you're a night owl, chances are you'll die early. Finnish scientists say night owls have a slightly increased risk of dying prematurely compared to early birds. But the good news is this is unlikely to be caused by staying up to the wee small hours of the morning and more likely to be caused by smoking and drinking. The findings, reported in the journal Chronobiology International, followed 22,976 people who were aged 24 in 1981. All of them were twins and followed up until 2018. Around 10,000 of the participants reported being night owls, while around 1,300 said they were early birds. The authors found the night owls were 9% more likely to have died by 2018 than the early birds. To investigate possible causes, the authors looked at education, daily alcohol consumption, smoking status and quantity, body mass index, and sleep duration. Now, in general, compared with early birds, night owls were younger and drank and smoked more, and the researchers say it's likely that smoking and alcohol largely caused the extra deaths and not sleeping habits. That conclusion was supported by the fact that night owls who were non-smokers were not at an increased risk of dying prematurely. As the world moves away from science-based medicine to more alternative treatments under the encouragement of the World Health Organization, there are growing concerns by medical doctors wanting to limit the harm being caused by developing some kind of regulating body. But that raises an important question. How do you regulate a witch doctor? Tim Mendham from Australian Skeptics says it's got to be about scientific evidence.
The alternative medicine areas, and there are those that are sort of more officially accepted, like chiropractic and Chinese medicine. And those things, they have their own professional bodies, right? The same way as doctors have a body, dentists have a body, nurses have a body, a medical body, and these things form part of the system in Australia where complaints come in and those bodies investigate. So you end up having chiropractors assessing chiropractors and Chinese medicine people assessing Chinese medicine practitioners. And they might have their own systems of doing it. There's a suggestion that why don't you have the same system throughout all medicine? If it is medicine, if it's not alternative woo medicine, if it is real medicine, why not have the same criteria? And the main criteria is evidence, of course. You know, you should have evidence of your techniques and what's underpinning all your treatments and things. And you should be able to point to that evidence.
There is no real scientific evidence to support things like acupuncture or Reiki or anything like that. It doesn't exist.
That's the problem. There is no evidence. So in a way, this is saying if you don't have the evidence, if you can't point to the evidence for your patients, right? If you can't be sort of upfront about the...
it's a bit like saying, why not have a psychics tribunal to judge all psychics if you have complaints about them?
There is to a certain extent. There is supposedly a professional body of psychics, but it's not very good at throwing people out.
You're kidding.
No. It's only an amateur thing, right? It's a club, right, as much as anything. The Australian Psychics Association was sort of being run for a while by...
the ones who cancel their meeting for unforeseen circumstances.
It's a problem everywhere if you get people who are very committed to a particular methodology checking other people, and if there are loopholes everywhere. Now, yeah, the modern-day medicine doctors get pulled up all the time by the medical associations and things, and some of them get banned for life. And I'm sure there are others that fall through the system and get away with saying things. The same thing happens to most medicine, but the thing is, let's try and add some sort of consistency so that you got evidence and so that you can give proper informed consent information to your patients. If you say there are risks involved, it might not work, it's going to cost you this much money, etc., and all these sort of issues that your patients should know, which does happen in science-based medicine, or should do, but it doesn't happen in a lot of alternative medical areas. You wonder how many cosmetic surgeons give full information to their clients so they know what the risks are. You wonder how many of the alternative medicine people, the chiropractors, the acupuncturists, the Reiki practitioners, the traditional Chinese medicine, all these other people, that how much information do they give to their clients, and can they point to any evidence that supports what they're doing? And in most cases, there ain't none, or they're not very good, but there is, and that's always an issue. You know, you've got to point to something that shows it works rather than just saying, I gave it to Bill Bloggs and he felt better. Yeah, that's not enough. So you need a single standard. That's what's being suggested by one particular critic of alternative medicine in the UK named Ed Zardos, who says that this sounds pretty reasonable. Ask for the evidence. Show me the evidence. It's what you do all the time. Someone says they can fly, you say, show me the evidence.
Well, that's what you do. You say, here's the evidence, and if there's no evidence, you let people know there's no scientific evidence to back this up. And if they still want that treatment, then fair enough.
Fair enough. You've signed the form and you will go ahead with it. Yeah, it's a reasonable thing to do for if you want to be seen as a medical practitioner, you should be able to act according to the rules. And one of the rules is evidence-based practice.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.